All right, let's talk a little bit about elasticity. There's 4 different types of elasticity to cover. Today, I'll just be talking about the elasticity of demand, supply, cross-price elasticity, and income elasticity we'll talk about another day. So first of all, elasticity of demand. What elasticity is a measurement of consumers' responsiveness to a change in price, right? The question is, we know that the law of demand says that when price increases, then the quantity demanded will decrease and vice versa. But then to dig a little bit deeper, how much, right? That's elasticity. So what will happen if price increases? How much will affect quantity demanded? Why should we be interested in this? Well, it's interesting to firms to determine how they're going to price and when and if they're going to put different kinds of things on sale. It's also useful when the government is calculating the economic impact of various taxes. And later we'll take a look at how elasticity kind of governs who pays more of an excise tax that we've previously covered. So first we'll start off with inelastic demand. Milk is a good which is typically thought of as having inelastic demand. You can see this little cartoon here. The woman is buying some milk, and she's happy that it's only 80 cents, but on the right panel it's still $2. It's $2.40, but she still needs it because the kids need milk in their cereal or whatnot. So an easy way to remember elastic, inelastic is that inelastic is insensitive to price changes. So if the price increases, the quantity demanded will fall a little, and if the price decreases, the quantity demanded will rise a little, so not very much. Inelastic demand curve is steep. You can see the change in price versus the change in quantity. Over here, the change in price is larger than the change in quantity on this graph. Say a 20% change in price, but only a 5% change in quantity over this portion of this demand curve. Some examples of inelastic demand are gasoline. You got to have it. You're going to buy it. People complain about the price of gas all the time, but it's not going to stop you from actually buying gas because, well, you got to drive your car, you got to get to work, and if you can't get to work, you can't make any money to buy anything. Milk is that example from that cartoon. Diapers, babies got to have diapers. Hot Cheetos, no, not really. That's just in there for a joke. Medical care, there's another example that we can go through later, like insulin for a diabetic would have a super inelastic demand, perhaps a perfectly inelastic demand where it doesn't matter the price, you're going to pay for it anyways. Other types of medical care would be an example. Toilet paper, got to have it. Some characteristics of inelastic goods is that they're usually things with few substitutes and or are necessities that you have, like the toilet paper example on the last page. If it's a small portion of your income, usually the price change doesn't impact you so greatly that you would give it up. Because you can bear that price change without having to change your habits much. If you got to have it now, you're going to buy it now. Kind of an airline ticket would be a great example of inelastic demand, right? So if I've got a meeting, I've got to get on this plane, I've got to get to Chicago by tomorrow, right? Well, I got to have it now. Last minute plane tickets are always more expensive because the airlines know this and they jack those prices up because they know that people coming up to the ticket counter at the last minute have a very inelastic demand for travel at that time. And the elasticity coefficient is a way that we have of measuring or calculating this. And you see here the equations, just a simple fraction for the elasticity coefficient. It's the percent change in quantity divided by the percent change in price. So in the example above, you can see that the percent change in quantity is 5 and the percent change in price is 20. So 5 divided by 20 is 0.25. So the elasticity coefficient represented on this graph is 0.25. I always like to remember this by thinking about my favorite McDonald's sandwich, the Quarter Pounder, which is Q then P, so quantity over price, think Quarter Pounder. I don't really know why, but that works for me to remember it. Maybe it'll work for you too. On the other side of the spectrum, we have elastic demand. Here's this guy with a really bad comb over, and he's buying some cola. and the cola tripled in price. No way, I don't need cola, right? You could substitute something else. You could drink milk, or you can drink orange juice, or you can just drink water if the cola is too expensive for you. Elastic means the quantity is sensitive to a change in price, and it's essentially just everything we said about inelastic demand, but from the opposite perspective. So when price increases, quantity demanded will fall a lot, and vice versa. When price decreases, quantity demanded will increase a lot. The elastic demand curve is flatter, and as you can see here, a 10% increase in price has caused a 15% drop in quantity on that graph there. And if you're taking notes, it's a good idea to put these graphs in your notes, both the inelastic and the elastic demand curves. Some examples: soda, like from the cartoon; a boat, you don't really need it; beef, you could substitute lots of things for beef: chicken, pork, tofu. Real estate, in terms of investing, if the price is too high, you can always rent, right? Pizza, gold, and if we look through some of the characteristics of those goods, some things with lots of substitutes, things that are luxury items, things that are a large portion of your income, things that you have plenty of time to decide on, right? You can wait for it to come on sale, so you might expect a different price in the future, or something that you have to think about, like the airline ticket example still holds here, right? If you're planning your trip and you buy your plane tickets a couple of months in advance, you're typically going to pay much less than if you buy your tickets last minute. And in this case, we see an elasticity coefficient of greater than 1. And again, you calculate that coefficient the same way: percent change in quantity divided by percent change in price. In the example above, we see an elasticity coefficient of 15% change in quantity divided by 10, so an elasticity coefficient of 1.5, which is greater than 1. And the larger the elasticity coefficient, the more elastic it is, right? So we can see here that, gasoline is very inelastic, beef is pretty elastic, real estate is a little bit more elastic, medical care, again, very inelastic, electricity, even less elastic, gold, that's very elastic, 2.6. Demand for insulin for diabetics. Here's that graph I was talking about earlier. It's a perfectly inelastic. You got to have it, otherwise, you're going to die. And so you can't use your money on anything else if you don't buy that insulin. A 45-degree line like that you can describe as unit elastic, though there's a little bit of a wrinkle to that, because unit elastic is actually only 1 point on that demand curve, or on any demand curve. And so if you measure it over a range and you get an elasticity coefficient of 1, then it is unit elastic over that range. The total revenue test is the last thing that I'll cover here, and the total revenue test is an easy way of finding out if a demand curve is elastic or inelastic. If you're not going to be able to see this, but if you take a rubber band and you hold it between two hands and you make a closed fist with your right hand or your left hand, looping your index finger of your right hand through the rubber band and your index finger of your left hand through the same rubber band, and you call one hand price and the other hand total revenue. When price goes up, total revenue will fall in an elastic situation, and vice versa. When price goes down, total revenue will rise. If you move one hand down, the other hand up, you should see the rubber band between your hands stretching, right? It's elastic, it's stretching. And the opposite is true for inelastic. Price and total revenue move in the same direction. For unit elastic, price moves, but total revenue doesn't move at all. So this is an example here of where we can use the total revenue test. So if we start at point A and we move the price from 10 down to 5, so your price hand moves downward, and we move to point B. So the total revenue at point A is the price 10 times the quantity is demanded, so that would be 1,000. And the total revenue at point B is the price 5 times quantity demanded, which would be 1,125. So total revenue goes up. So as price goes down, total revenue goes up. So you should find that by the total revenue test, demand is elastic. And in fact, that's all you need to say on the AP test. If you were presented with this and it said, find if this section of the demand curve is elastic or inelastic or unit elastic and explain, all you would really need to say is section AB is elastic by the total revenue test. Now, it never hurts to show those calculations, I figured out what total revenue is here, and I figured out what total revenue is there, and explain the total revenue test. But merely saying that it's elastic by the total revenue test should be sufficient for full credit for the explanation of the AP test. All right, thank you.